In this video, let us discuss what is scalar and vector quantity in depth. We all of us are introduced to scalars and vectors in school level itself. Here in this video, I am going to add a few points which we have not come across in our school level. Let me start this video by defining what is a physical quantity. Any quantity which we can define and measured or can be termed as a physical quantity. The physical quantities can be classified into two groups as scalar quantities and vector quantities. Okay, let's see what are scalars. Any physical quantity which has only magnitude and no direction is called as a scalar quantity. Example: mass, speed, distance, time, volume, density, temperature are some of the scalar quantities. These scalar quantities are just represented by their numerical values, and these quantities do not specify any direction. And they can be simply represented by numbers with their units. For example, the temperature is represented as 5 degrees centigrade or 10 degree Fahrenheit. If we talk about time, we say 5 seconds, 10 seconds, 1 hour. And if we talk about mass, 200 kg, 1 ton. So we just write the numbers and the units, and these values do not represent any or do not give any information about direction. See, if we want to add two scalars, or if we want to do a subtraction or multiplication of the scalar quantities, they are simply controlled or governed by algebraic rules. Or we can do a simple arithmetic like addition or subtraction, because the scalar quantities involve only magnitudes. The scalar quantities are called as one-dimensional quantity because their magnitudes are same in all directions, and we cannot any scalar quantities into two components like a horizontal component and vertical component, as these quantities have same values regardless of any direction. And a scalar quantity is represented by simple alphabets. For example, T for time, capital T for temperature, capital M for mass. And the measurements of the scalar quantities are very, very simple. Next, let us see about vector quantities. Any fundamental or any physical quantity which has both magnitude and direction is called a vector quantity. Some of the examples to highlight are displacement, acceleration, force, linear momentum, angular velocity, angular momentum, electric field, polarization are some. Generally, the vector quantities are represented by by both their numerical values, and they also specify the direction by a unit vector. Unlike scalar quantity, the vector quantities are governed by special set of rules. Example, for addition and subtraction, we do vector addition and vector subtraction, not like our usual algebraic arithmetic. And the vector quantities are represented by numbers with their units and direction. For example, so if I talk about displacement, I'll be representing it's 5 kilometer north. If I say velocity, I'll be saying 50 meter per second in the east direction. If I talk about force, then I have to mention So a force of 5 Newton is acting in the south direction. So each vector quantity is represented by a number as well as the direction. Vector quantities are maybe one dimensional, two dimensional, or three dimensional. This is because any change in the quantity may be either in the magnitude or in the direction, or it may happen in both. So, so generally, if there is any change occupying a direction, for example, we have x axis, y axis, z axis. So the change may be in x axis alone, so we call it as in one dimensional. If it is in both x axis and y axis, then we call it as a two dimensional. If there is a change involving x, y, and z, we call it as a three dimensional. We can resolve vector quantities into two components as horizontal component and vertical component using the sine and cosine of the adjacent angle. And we represent a vector quantity by a bold letters with an arrowhead. For example, force is represented by F vector. So you can find an arrowhead over that F. So this represents it's a vector quantity. And the measurement of the vector quantities are highly complex.